Okay, hey guys. 6.3 today. This is the last content that you'll get before your quiz, which is this Friday. So you'll do this today. We'll have a review day on Thursday, and then you'll take a quiz Friday. Today, your target is function operations and compositions. Compositions are going to become pretty important for the rest of your high school math career, both for the rest of this class, pre-calc, and in calculus for that matter. So I just want to lead off with kind of a review of some stuff you should already know today. This is not on your notes, but I just want to give you kind of a heads up of some things that will be useful here. So let me just create a function. We'll just say f of x is, make it a basic like quadratic here, 2x squared plus 3x plus 1. So the input into this function is x. If I asked you to find f of 3, you would just go and obviously replace x with 3 everywhere it shows up, and you could evaluate that. You could find what that equals. That's just numeric, so it's something. You could do that. If I asked you for f of a, well, I'm just going to replace x with a. The input is now a. Right? So really what that's going to amount to is what our function looks like exactly up there with an a in place of x. 2a squared plus 3a plus 1. So it's no different really than what we started with. I just have an a as the input now. What gets a little more interesting is I could have larger things be the input. So for example, f of a plus b. So now I have a whole sum that's being input. Instead of writing an x in this place, I'm going to write an a plus b. And there's still the 2 out front. There's still the square value. It's just I'm replacing the x with the a plus b. And then I'm going to have plus 3 instead of x, a plus b. And then on the end, I'd have the plus 1 still. This can be all simplified down, actually. This would be 2 times a squared plus 2ab plus b squared plus 3a plus 3b plus 1. And you could clean all of that up actually a little bit more. We'll do that later in the video. I could combine all my like terms there. I just wanted you to get the idea that the input can be things larger than one quantity. Here it was a plus b. So I had to replace x with that whole quantity. Okay, so let's move on. You have a bunch of examples in your notes of some rational exponent functions and how you could do arithmetic with those, but I'll move on to example 1 and show you that. So if I have f of x defined as negative 5x to the 1/3 plus g of x, which is 15x to the 1/3, this one's pretty simple. They both have x to the 1/3, so they're like terms. So I can just add their coefficients. This negative 5 plus 15 would just be 10, and that x to the 1/3 stays. Okay, I could do the exact same thing for f of x minus g of x. I have 5x to the 1/3, but now minus 15x to the 1/3. And then I'm going to subtract, so I'll get negative 20, and x to the 1/3 stays. So if I have addition or subtraction, I'm basically just combining like terms and adding or subtracting the coefficients. Now for multiplication, I'd have negative 5x to the 1/3 times 15x to the 1/3. What I'm going to do is multiply these coefficients out front now. So I have negative 5 times 15 is negative 75. But now I have x to the 1/3 times x to the 1/3. And then remember, I'm adding my exponents here, so 1/3 plus 1/3 would be x to the 2/3 is what I'm going to get. Okay. And then on the last one here, I'm dividing, so I'm taking my negative 15 x to the 1/3, dividing it by the 15 x to the 1/3. But then I notice that I have x to the 1/3 over x to the 1/3, and anything divided by itself is 1, so x to the 1/3 divided by x to the 1/3 is effectively 1, so I can get rid of that. So I just have negative 5 over 15, reducing, I get negative 1/3. Okay, so moving on to function compositions. I did not do example 2 from your notes. I want you guys to go ahead and try that. You can check on our Google Drive folder, and the answers for all of these notes will be on there, so you can verify that you're doing them correctly. And I'm going to move to the next page. So function compositions basically means we're plugging a function into another function. In this case, in this example, I have f of x equals x squared, g of x is x minus 5, and I want f of g of 7. Well, g of 7 is just some value, so I have to figure out what that is first. G of 7, if I plug 7 in for g up here, so into this function, I have 7 minus 5, and I get 2. So g of 7, I'm really just replacing this now. Since I know g of 7 is 2, I'm really just looking for what f of 2 is. And then if I find f of 2, I just plug 2 into this function, which should just be 2 squared, and I get 4. So you can think of it more in terms of evaluating a function first and then taking that value and evaluating a different function at that point. The next example is very similar, so you can look through that. But I want to look at an example of not getting a numeric answer, but plugging a function into a function and getting a new function back. So this would be if I wasn't plugging in a value, but I was just plugging in purely a function of x. So f of g of x. So I'm going to take what x is, what f of x is. I know f of x is just x squared, so this is going to be something squared. But what's that something? It's whatever g of x is. So I'm going to plug x minus 5 in there, as you can see from the notes on the right over here. You got to remember how to simplify that x minus 5 squared. That gets me this x squared minus 10x plus 25. Remember, that is not x squared minus 25 or plus 25 or I don't know, whatever mistake we were making before. That is not true, so make sure you're not doing that here. Okay, and then I could do it in the other order. So I'm plugging whatever f of x is into g of x. Well, I know g of x is something minus 5. But what am I plugging into this now? I'm plugging in the f of x function, which is just x squared. So this would just simplify. I don't need the parentheses there. I just get x squared minus 5 as evidenced over here. Okay, so let's see an example of that. So I have a function f of x, I have a function g of x, I want to find f of g of 2. So I need to find what g of 2 is first. Well, g of 2, if I plug 2 into this function right here, I'm just going to get 2 plus 5 is 7. So really f of g of 2, well, I know what g of 2 is, that's just 7, so this is f of 7. Well, then I'm going to plug 7 into this function, f of x. F of 7 is going to be 3 times 7 minus 1, which is 20. So f of g of 2 is 20. If I'm plugging in a numeric value to this, I should get a numeric value back. Where on the next example, let's see, number 4, I'm plugging a function into a function. I'm still going to have an x in there. I'm not plugging in a numeric value to either of these. So I'm going to take g of x, which is x squared plus 1, and I'm going to plug that into f here. So I'm going to replace my x with that basically. I know that f of x is going to be 4 times something minus 2. That something now is just my g of x. But I know what that is. It's x squared plus 1 minus 2, and then I just have to clean all of that up. If I go ahead and do that, that's 4x squared plus 4 minus 2 is plus 2. If I do it in the other order, so now I'm going to replace the x value in the function g of x with f of x. So g of f of x is just going to be, well, my g of x function is x squared, but I'm replacing the x with f of x. So it's f of x squared plus 1. But f of x is 4x minus 2. So this is 4x minus 2 squared plus 1. Make myself a little divider line here. If I go and expand out 4x minus 2 squared, you can go ahead and do that, but it gets me 16x squared. That's what 4x squared is. And then 2 of these products, so the product is negative 8x, 2 of those would be negative 16x. Negative 2 squared is plus 4. And then I still have that plus 1 on the end. So this, at the end of the day, is going to simplify to 16x squared minus 16x plus 5 at the end. Okay. I know that was probably a lot, and we'll review it tomorrow if you need it, but I'd like you guys to practice it now on the homework. So what I'd like you to do before you do that, finish the notes. We only did about half the problems there, so finish those up. Check that key online if you want to make sure you're doing it right. So the key is on the Google Drive folder. Okay. Then work on the worksheet 6.3. If you finish all of that early, remember that Canvas quiz, the Chapter 6 Canvas homework quiz, is due by Thursday night, so you can get a head start on that with the rest of your time. I'll see you tomorrow, and hopefully you write your questions down if you have any, so we can cover them tomorrow at the beginning of class.